Okay, now let's welcome the next speaker, Wang from Australia.
Hi, good morning. That's loud. My name is Han, and I'm from Australia. I'm a PhD student at the University of Melbourne and majoring in electrical and electronic engineering. So today I'm going to present my PhD project, Flexibility and Grid Services from Distributed Multi-Energy System. Climate change is real, and it's happening. There are a lot of ways to fight against the climate change, and one way is to decarbonize our energy sectors. So how can we do this? For example, we can build more renewable energy resources to replace those high-polluting fossil-fueled power plants. And we can also build distributed energy resources, such as rooftop solar panels and batteries and small-scale generators at a household level or community level. So once we get the clean electricity, we can also use those clean electricity to electrify other energy sectors, such as heating, cooling, and transportations. However, it is not as simple as it sounds. Why? So our power system so we need a balance in our power systems, which means we have to, the supply has to meet the demand at all the time to maintain a certain frequency in the system. For example, 50 Hz or 60 Hz. Our utilities, generators, and our devices are all designed to operate within this certain frequency band. So that's why we need kind of flexibilities in the power systems to maintain the balance between supply and demand and to maintain the frequency within this certain bound. So imagine you live in a world with a lot of wind and solar power, and this is a really hot day. Everyone starts turning on their air conditioning, and there is no wind blow. So our supply cannot meet our demand. Your frequency drop, and then you get the blackout, no Wi-Fi. So it's a really important question. How can we keep the lights on? So my research is really trying to answer this question. How can we successfully and economically integrate those renewable energy resources and distributed energy resources into the energy system? Well, to keep our light on, to make sure that you have Wi-Fi all the time. So one way to do this is to exploit the flexibilities from customers' participation, in another word, from us. So how can we do this? For example, if we have a battery, we can operate this battery more smartly. For example, charge the battery when there's a generation surplus from your solar panels or even your neighborhood's solar panels. Or we can change the time that we turn on the electric boilers to get the hot water and store them in the hot water tank to be used later on. By exploiting those flexibilities, we can also provide great services. For example, we can participate in frequency control ancillary services to help the system operator to maintain the frequency within that certain bound. Or we can provide reliability services, meaning that we could use our generations to restore customers or restore our neighbors when there is a contingency. So by doing so, we can contribute to the system's reliability and security. Well, on the other hand, this also gave us a lot of money to the customers and our communities. So we have developed a technical economic framework to model the distributed energy, multi-energy systems. So basically in this framework, we can optimize the operation of different technologies and loads to achieve certain objectives. For example, we can maximize the profit of the overall profit of the customers or communities. Or we can avoid electricity import and export if you want to go off-grid. So from this model, we can get what are the energy consumptions from us and what is the district cash flow, like how much money we can make, and also emissions and the services that we can provide it to the wider grid. So this model is tested in the context of Australia and have a great value to apply to other countries too. So from the studies, we found out that from a technical perspective, those flexibilities from us, from the customer participation, can significantly aid the integration of the renewable energy resources, and as well as give reliabilities and securities to the system operator. And from an economic perspective, this will also bring us significant economic benefits, like money, to the customers of the communities. Yeah, so that's my presentation. Any questions?
Do we have any questions? Yeah, over there.
Hi, interesting topic, and I'm wondering that, well, let's say solar energy and also wind energy, in order to make them function, you also need energy. Plus, to get enough energy to actually support like the whole country, let's just say USA, you actually need very big land to operate that. How is that going to work?
So you mean to operate wind and solar, you need a lot of land, or you mean to have wind and solar in the system, which you need backup generators?
Yeah, basically, and also biodiesel, to they need big land to actually produce those plants and then burn them.
Well, that's a very interesting topic, but because I'm electrical engineering, so I'm not very sure about this, but I will try to answer your questions. So in Australia, what we have is we have a lot of rooftop PV, which is installed on your rooftop. So this doesn't really need a lot of land to do so. And yeah, that's...
Okay.
Sorry, I'm not an expert in the environmental engineering or stuff. Sorry.
Can I ask one more question?
Yeah.
Yeah. Then you said battery. Then those batteries, are they similar to Tesla batteries, the small ones? But Tesla batteries are actually use rare materials that actually is bad for the environment. How do you explain that then? Is it bad too?
Well, again, this is not quite my expertise. Sorry, I couldn't answer that question.
It's not a problem.
Okay.
Thank you.
We have some more questions here. We have one there and then there.
Hello. So I saw a logo for a radioactive power plant, and I'm asking for your personal opinion. Do you think that radioactive power plants are a viable source of energy for the future?
Which is radio power plant, you mean?
Nuclear power plant, I mean.
Oh, nuclear power plant. Well, that's a very hot topic. I think nuclear power plant, so on the one hand, is very clean, but on the other hand, is like a stable generation. You can't change nuclear very quickly, so it's normally act as a base load. But I think nuclear power plant has a huge potential to decarbonize our energy sectors.
Okay, thank you.
Yeah. But that's only my personal opinion. It doesn't represent anything.
Last question. Last question.
So generally, one of the biggest problems with solar energy is this here.
There's. There it is.
So generally, one of the biggest problems with solar energy is this entire swan graph thing, in which you have the most production during the day, and then you have the least production in the nighttime, which is when most electricity is used.
Yeah.
How do you plan? But that means that that when the people will be producing most energy in their households, from the sun, would also be the point where there's the least demand and most production, which means that the value of this electricity would be very low at that point, and then later at the evenings when there's no sun, they wouldn't earn, like, would they really be able to earn very much because they would be producing when there's a lowest demand for it?
I mean, exactly. That's the problem we are trying to solve. So currently what's happening is in Australia, a lot of households have a rooftop PV, and during the noon, there's a huge generation, but no one is at home. So you will get a generation surplus, and there are a lot of people are exporting their electricities, and this will impose like a problem on the distribution network. So in this project, we are trying to solve these questions. So there are a lot of ways that you can address those questions using the flexible resources. For example, you can use a battery. You can charge the battery when there is a generation surplus, or you can turn on your electric boilers, to generate hot water and to be used in the evening for the shower, or also. There is also thermal inertials in the building, which means you can pre-cool or preheat your apartment or your house. So we can use a lot of flexible resources to address this problem. And this is exactly what this project is trying to answer.
Okay, thank you.
That's all time we had, so thank you.
Thank you.